Okay, we are in the start of a new chapter, chapter 6, inverse and radical expressions and equations and functions. It's all about square roots. And inverse functions, undoing, and other types of functions, like for coding and things like that. So we're going to start out with just adding, subtracting, multiplying, and dividing functions. So especially when you code things, so like think about a register. If you had worked at like a Chick-fil-A or Panera Bread and you were to buy a sandwich, let's say this represents the cost of a sandwich, and then somebody else was buying a brownie with that sandwich, and you type in the register F for the sandwich and then G for the brownie, your computer would add them together. What would it be doing with the two functions? What would that one overall function be? It would be this function. So you would take 4x squared, add it to 6x squared, 6x and negative x, negative 9 and 2. And they said, okay, what about subtraction? It's the same thing. You're going to subtract them. But remember, when you subtract, you're taking 4x squared plus 6x minus 9 and then subtracting this entire quantity. So you have to remember to distribute the negative. When you do that, you should end up with this polynomial. And then here, where it's a filled in circle, is multiplication. You're going to take this quantity and multiply it to this quantity. So you're going to FOIL. You're going to get this, then you combine like terms. And then for division, you're putting one polynomial on top of another. Now be careful. You can't just simplify right here because this 2x is connected to this 1. Okay, you can't just chop it. So this is your answer. But these are nice, pretty polynomials like we had last chapter. When you have a division of polynomials here, division has some errors. What can't you divide by in mathematics is 0. So you have to tell your reader, by the way, there's a number you can't use for this. The reader can put any number in here and we won't have errors. But if the reader puts a number, or a person reading this puts a number in here, and they put in negative 3/4, you're going to get 0. You don't want that. So you're going to tell the reader, do not let this be negative 3/4. Now, how did they do it? They set the denominator equal to 0 because they don't want it to be 0. They need to figure out when it will be 0. And that's your answer. Okay, so you say you don't want it to be that. So this is your overall answer. Okay? All right. So adding, subtracting, multiplying, and dividing. Also in this section, it says Cody and Sam are super excited for Justin Bieber's new cologne to come out. Luckily, their moms are on it and found discounts for $10 off and 20% off, and the boys can use both. The girls working at the counter did not pay attention to math class and just used the coupons how the boys handed them to her. Cody used his $10 off first and then 20%, and Sam used his 20% off and then the 10. Who got the best deal? Now, if you made up a fake price for the cologne, you could figure it out. But this is applying a function and then applying another one. You're not adding two functions. You're not subtracting, multiplying, or dividing. You're using one and then using another. So that's called composition of functions. When you use one and use another. Okay. So for one, I don't know why we used M and S. I think in the class we used two different names. We used M or S, like a Matt or Steve. So the one boy, we'll just call it Cody because that's our example. He took $10 off and then used 20% off. And then Sam, okay, took 20% off and then 10. So the first thing Cody did was take $10 off, and then of that took 20% off. Well, when you take 20% off, you're essentially spending 80%. When you simplify, this is what you're going to get. And then here you're taking 20% off first, so getting 80% and then taking $10 off. So they're the same, other than this is always removing 10 and that would be always removing 8. So really, Sam got the better deal. Here's the thing. I'm not going to make you do this, but this is where composition of functions, this is something relatable that you can reflect back to. What I am going to have you do is this. So in composition of functions, it is denoted by f of g, or f of g of x. So we're replacing f of x with an entire function, g of x. So the domain is set for the values that go into g, okay, at the range of g. So all they want you to do here is, if they give you f and they give you g, and they want you to find f of g of x, f is your outermost function. You're going to take an entire function g and put it in where f is. So I'm going to write my f function, because that's the last hoop I jumped through, and I write, it's x squared plus 4. So you're going to write parentheses, squared plus 4, and then you're going to replace what x is with 2x. And then you simplify, 4x squared plus 4. I'm going to write it on a brand new sheet because I think this is confusing. Okay. Here they have g of f of x. So what they're saying is we're going to have g as our outermost function, and we're going to replace x with f of x. Well, x is going to go into f, and then it's going to go into g. So g is my outermost layer. So g is 2x, and I'm going to replace x with f of x, and f of x is x squared plus 4. So my answer is 2x squared plus 8. And that's it. Here, it's the same thing. The notation is just a little bit different. It depends on a textbook you get, which notation you get. So this is the same thing as saying f of g of x, so we're going to do it again. So x is going to go into g. Well, then you get negative 2x, and then that negative 2x is going to go into f. So f is your outermost function. It's going to be negative 2 times the quantity x squared plus 3. We're replacing x now with an entire function. That's it. The end. And this is g of f of x. So g is your outermost function, 2x, f of x is x squared plus 4. So your answer is 2x squared plus 8. The end. Okay, and the last one, we're actually substituting numbers. Now we could do this how we did before and put f as your outermost function and do negative 2x squared plus 3, and then put g in your function next and saying that's negative 2x, but we know x is now going to be 2, and substitute that way. Or we could say, okay, 2 is going to go into g. Think about it logically. Well, if 2 goes into g, that's negative 4. And now we put negative 4 into f. So that's going to be 16 times negative 2, which is negative 32. Negative 32 plus 3 is negative 29. So stick to this method if you want to stay consistent, or just plug in 2 into g, negative 4, plug in negative 4 into f, negative 29. And here, what this is saying is take negative 2 and plug it into f, and whatever that is, plug it in again. Well, f is negative 2x squared plus 3. And f again is negative 2x squared plus 3. And we're not having x, we're having negative 2. So when you simplify that, you're going to get 4 plus 3 squared plus 3. You're going to get negative 7 squared plus 3. You're going to get 49 times negative 2 plus 3. And then you're going to get negative 98 plus 3, which is negative 95. Is this accurate? Check to make sure. Negative 2 squared times negative 2 squared times negative 2 plus 3 squared times negative 2 plus 3. I think so. Okay. so that's it for 6-1. What I would suggest doing is now just trying it on your own. Do the 6.1 homework quiz now instead of tomorrow, and then I'll put a video up of that. And then if you're comfortable with that, then see what you need to do for your homework. Like I said, it's just like class. You don't have to do all of it, okay? Start marking down on your list questions you have on homework too, and then I'll make a video of that.